And then let's probably start. So just one more time, please. Do you see my presentation?
Yeah. Mm-hmm.
Okay, great. Okay, let's move to next to the agenda. So you probably are familiar with with our name of the topic. You actually can see it on my background. Yeah, so we will start from reminder about the GitOps approach. What is that? Probably somebody is not aware, so we will just remind for that persons, and if not, then just we will meet with that approach. Then we will check some basics about the Flux. Actually, it's the main subject today. For us, it's like GitOps toolkit that will help us to implement the GitOps approach. And then we will check all of the features of this product, make some implementation demo as usual, um, and perform some Q&A session. Maybe you will have any questions or something like that. Okay, then let's go about the GitOps. So actually, GitOps, it's some kind of approach that helps you to manage your infrastructure and applications using the Git repositories. Like to check this, let's don't care about the definition. Let's check the schema. Yeah, so it's easier than explain here. So you have some Git repository. In this Git repository, you will put some infrastructure definition files like Terraform files or something like that, and some application infra. For example, you manage your application with Kubernetes and with a Helm chart, or probably with a simple manifest and then customize them. So you just push everything to the Git repository, and this will launch some GitOps tool that pull the information from your Git and then apply it to your cluster. So everything is pretty straightforward. So you don't need any kind of, for example, approval system, because the approval system is already presented in Git. Yeah, if you want to perform some changes, just create a pull request, get the approvals, merge it, and voila. So the same for the application code. So, but in this case, you will also have some CI system. Yeah, because usually the artifact in case of the Kubernetes, it's the Docker images. Yeah, so in this case, you need some CI system that will build your artifact. And then this CI tool will actually push some changes to the Git repo with your application infra. For example, it will update the um, tag of the images in your manifest. And again, it will trigger the GitOps tool and it will perform all of the necessary changes for you. So it's pretty straightforward approach, and it's pretty popular. So you probably heard about some tool that is called Argo CD. Yeah, so it works almost in the same way. Yeah. Now let's check what is the Flux and what are the main features of the Flux. So actually, the Flux, it's a set of controllers. So it works in the way that is similar to Kubernetes operators. Yeah, you have some custom resources where you define the configurations, and the Flux components actually will just consume that information, reconcile it, and perform the actions. So, and actually Flux, it's the Cloud Native Compute Foundation. Now it's graduated project. Some time ago, it was the incubator project. So for now, you can just easily use it in the production. For example, on my project where I work right now, so we have a plan just to migrate all of the continuous delivery stuff to Flux. What about the architecture? So the Flux has 4 main controllers and 2 additional controllers. Yeah. Let's like check this general schema and then just meet with the rest of the controllers like one by one. So when you bootstrap your like your Flux ecosystem to the Kubernetes, it will just point to the source controller to grab any kind of like artifacts or necessary information from the sources. So it can be like OCI repositories, Git repositories, S3 buckets, or for example, Helm repositories. So based on that, like once the source of your code is collected, then the source controller can trigger the either customization controller or either Helm controller. So it depends on the type of your artifact. So if you have a Helm chart in that stores, so in this case, it will trigger the Helm controller. In case if it's like a plain text manifest with a customized file, it will just trigger the customized controller. And once any of these controller will gather the information about your artifacts, it will just deploy it to the cluster. And based on the cluster policies, it like might send some alerts to the notification controller. So in this case, notification controller just can use different notification channels to notify about the events in the system, like failures of the release or success of the release. So something like that. So this schema is like pretty general. Let's like discuss the actually bootstrap of the Flux. So Flux actually manage its own manifest in the same way like it manage the manifest for your application. So when you perform the Flux bootstrap command, it will just push some manifests that describe the Flux microservices in some Git repo and set some deployments key. Yeah, about the deployments keys and the approach, how it will interact with the Git repo, we will talk later. Yeah, but the second step here will be installation of the controller actually from that manifest. So it will, on first stage, it will just render the manifest and push them to the Git repo. On the second stage, it will just like install that controllers from the manifest in your Git repo. And for the controllers, it will set this private key. So after this, the controllers, the source controller, for example, will be able to reconcile back the Git repository and actually like have a fresh version of the manifests and fresh version of the Flux system from the Git repo. So like after that, like the first stage is like not applicable here. So this is the second stage. Yeah, so the Flux components will reconcile itself from the Git repository. And actually it will also reconcile all of them, like your configuration from the Git repository. And in case, for example, if something will happen with your cluster, you can just, again, perform the Flux bootstrap command and point it to your repository. So it will install back Flux to your cluster and actually all of the components that has the configuration in this Flux repository. So it's like gives you ability to have a persistence. And we will see how this works actually on the implementation demo. Now, what about the components? So as I mentioned, we have 4 different components here. Yeah, so source controller, actually, it has some basic resources like Git repository, bucket, or ICI registry. And actually, there you can define all of the configurations for that sources. So the source controller will reconcile that custom resources. And based on the type of the custom resource, it will perform the pooling of the artifacts to your cluster. The customized controller just actually works with one custom resource that is called um, customization. So in this case, like you will point in the customization configuration, you just point to which source it must like point the source where the customization controller must gather the artifact, and actually you put some configuration like how this customization must be applied. But again, it used like the same approach, like a customized tool that you are probably using. So the Helm controller contains the information about and operate with the Helm releases. So you create the Helm release custom resources, and based on that configuration, it will just install that Helm charts to your cluster. So notification controller actually operates with a bigger amount of the resources like alerts, the providers, notification channels, and also webhooks. So we will just take a look on it like later, because it's like hard to describe all of that stuff by word. So it's easier to see it one time. Yeah, it's about the controllers. So it's for main controllers. Additionally, we have two extra controllers that are related to the image pooling and image automation. So we have some separate section for the image automation. Yes, how the source controller works. So as I mentioned before, we have here. Actually, here is presented three type of the resources, but we have four. So the OCI repository will be also presented here. So you create all of that stuff, then it will be applied to the Kubernetes API, and source controller will just gather the artifact based on that configurations. And some consumers, actually consumers here are meant by like customization or Helm releases that will use that artifacts to make the deployment. So here on this screen, you have set of the features that are listed like for the source controller. Yeah, so in this case, the most general things are like ability to authenticate to the remote source using the different mechanisms, make the packages from the raw manifests in case if it's needed, make the verification of your artifacts with some signatures, and actually you can also integrate some custom resources, your own resources with that sources, and then just reuse it for your own operators. So something like that. Let's move to the customized controller. So in this case, like customized controller works with the Git repository. And actually, it can also work with the buckets and with OCI registries, but this is not mentioned on this diagram. So just for your information, it's like a diagram from the official site. So it's how they present this. But especially from my side, I just like to add here more resources, so this will be more transparent. So you create some Git repository and customization configuration to the Kubernetes API. So the source controller will reconcile the Git repository information, and the customization controller, like using the information from the source controller, actually will reconcile the customization custom resource. And in this case, it will just render the templates, actually manifests, and then just apply it to the cluster. So actually that's all that this controller performs. But there are many features here. So besides the deployment of the manifest, it can also perform the decryption of some sensitive data. So about the decryption, we will talk later. Then make some changes for the multi-tenancy support. So again, it's a part of our next topic. Make some pruning mechanisms for deletion and garbage collecting. And also it allows you to make health assessment. So it supports the custom health checks. So in the health checks, custom health checks, you will be able to like define a list of the resources that must be monitored. So in this case, like your deployment of this customize will be successful in case if all of the health checks will be successful. Yeah, and by the health checks, it just gather the information from the status field of the resources. So it means that that for the health checks, you will be able to use any kind of the Kubernetes resources that has a status field. Now the Helm controller. So just one more sec. So the Helm controller operates with the Helm repository, custom resources, Helm charts. Actually, in this case, we should also add the OCI registry custom resource because like this controller also operates with it, and like the Helm releases. So in this case, like the Helm chart resource use the Helm repository so to gather the information about the chart, and the Helm release use the Helm chart resource to make the installation. But in some cases, you just can omit usage of this Helm chart resource. Like not really omit, but like do not create it by your own and make a deal with the Helm release. So the Helm release resource will create the Helm chart resource based on your template, like we have with deployments or stateful sets in the Kubernetes. So it depends on your needs. If you want to perform like installation of the same chart multiple times, so in this case it's like easier to create it manually, and after that just point the Helm release to that Helm chart. Or if you just want to install it one more time, so don't care about this Helm chart, just define everything in a Helm release. So I'll show the example actually of the code that describes this behavior. So once we will apply all of these custom resources, so the source controller will gather the information about the Helm repository. Actually, it's Helm repository manifests that contains information about the charts and all of the supported versions. So it can be different sources. It can be, for example, the Docker repositories. Actually, you can also collect information about the charts from the buckets like S3, from the Git repositories, and etc. So it depends on how you will configure the information for the Helm repository. So the source controller will grab this information and pull the charts for you, and the Helm controller will read the information about the release and actually make a Helm release. Probably it will just notify you if you will have the appropriate policies configured. So it depends like how you will deal with this. Then like here are the set of the features, and actually most of that features actually I just described on the previous slide. Yeah, but the most interesting features here, it's ability to perform the Helm tests and make the automatic rollbacks. So in case if something went wrong with your release, the Flux will perform the rollback. And one more interesting mechanism that I'm happy to have, it's like post-rendering. So beside the installation of the Helm release, the Flux allows you to make some post-rendering customization and apply some patches to the resources and etc. Because sometimes happens that you want to install some community chart that like doesn't allow that feature that you need. So in this case, you can add post-render changes and like do not fork the original chart, just patch it on fly. And one more interesting feature, it's changing of the release status. It's mostly related to the Git Git systems like GitHub or GitLab. So it allows you to change the status of your commits and actually notify the end users that the artifacts are deployed. Okay, and notification controller. So it's pretty straightforward. So you perform any kind of customization or Helm releasing, or for example, pulling of the registry. So all of that events are collected by notification controller and will be pushed to some notification channel. So actually there are a lot of different notification channels there. Like HTTP webhooks, or for example, Slack or Teams, or even the Telegram. So it depends like on the end channel that you will be need. And like not too many things about this service. So this service just help you like to notify the end users about any kind of events in your Flux ecosystem and any kind of the releases or something like that. Okay, so it was like the main basic things, and we are ready to move to the advanced topics like that contains the information about some advanced features. The first thing actually that great to discuss, it's the repository structure, because as we use the GitOps approach, we will perform all of the operations through the Git. So we will commit our changes and the commit will be actually presented in the cluster. So we need to find our like great structure. So we can use one of these three cases. The first case, it's the mono repository. You have, for example, the clusters directory, and in each subfolder here, we will have the Flux ecosystem configuration for for each cluster. And beside that, we will have some reference to the infra and apps folders. So in this case, like we will manage the Flux ecosystem in a separate folder, and our application and infrastructure components also in the separate folders. And like substructure of these infra and apps folders actually are similar. So the subfolders here will be the names of the environments. And mostly if you will have some common components, you can just define the base and then just put everything to base and refer in the manifest, in the production or staging, refer to the manifest in base. Yeah, but like these internal like dependencies, I don't know, probably it has some risks, like to change the common stuff. So I don't know how it's better, like store the state for each environment separately and do not have the coupling between them, or just like have some shared kernel between the environments. So, but again, this is out of topic. It's just my minds about this. So in the infrastructure, you probably can store the config maps, so any kind of Kubernetes resources. So just put the manifest in the folder, and it will be automatically reproduced in the cluster. The config maps probably, I don't know, the secrets. So yeah, the Flux allows you to perform the encryption of the secret, so you can easily store it inside of the inside of your Git. And probably the information about some like infrastructure components or applications, like I don't know, for example, cert manager. Yeah, that is not related actually to the applications, but mostly used by other applications. So by the applications can be defined here like your own microservices. So and the structure will be actually the same. Another approach is repository per team. So you have almost the same structure, but beside the apps, here, you have the teams folder, and each team perform the development of some applications and deploy it to some specific environment. So in this case, when you use this second approach, um, it will be like easier to control which teams will have the access to some specific environments. And the last approach is the repo per application. So you have source of your application, and then just deploy folder with like manifest that contain the configurations and custom resources for the Flux. So for example, in this manifest files, this can be the file or this can be actually the folder. So it depends on your needs. So you can have all of the necessary manifests, and like the Flux will automatically grab it from this deploy folder and just make the deployments to the cluster. Probably one more possible repo structure here, it's repository per environment. But I don't know, like too many use cases, yeah, possible use cases. So probably you need to choose according to the requirement or to your work style. Yeah, but just remember these basic approaches, and we will use one of them. Now, webhooks. So by default, Flux works in like with a pool-based model. So what it means? It means like that during some intervals, it will try to pull your repository and then gather the information about the changes, and if changes were detected. So in this case, it will apply these changes to the cluster. However, with the webhooks, you will be able like to add some like push ability. So in this case, the like you can configure your repository just to send some HTTP webhooks. So on the Flux side, the notification controller will work as a receiver. So it will receive the webhooks from your repositories and then just trigger the appropriate resources that must reconcile the sub resources. For example, you changed some I don't know, Helm release definition in your repository. Yeah, so the repository will push the notification controller with a webhook, and the web notification controller will push the Helm controller, and Helm controller will perform the reconciliation of that resource. So, but again, so there is no big change difference. Yeah, like you can configure the pull mechanism to make a pull every 1 minute. So this will be totally enough to do not perform any kind of webhooks. Or if you want to have the changes as soon as possible, so in this case, like the push model will work for you. So just configure the like endpoint for your notification controller that will be uh, available from the outside of your cluster, and configure your repo to send the webhook to the Flux, and voila. So now the secrets encryption. It's a very interesting topic that has a different approaches. So you can use any approach based on your needs. But I just collected all of them for you, so you will be able like you will be able to meet with them and then choose one that will be best for you, or develop your own. So the first approach is just to use the Kubernetes secrets. So refer to that secrets and create the secrets for Kubernetes manually, or use some external mechanism to create the secrets to your cluster. So do not store it in the Git, and just create it actually by your own manually, or I don't know how you will perform this. By default, the Kubernetes secrets are not encrypted. So in this case, you will be need to think how you will proceed with this, like with unencrypted secrets, or you will enable the encryption in the Kubernetes control plane. So in this case, all of the secrets will be encrypted. However, it will be encrypted just only in the storage. So through the Kubernetes API, it still will be base 64 decoded. So just think about this. So we have also some secrets decryption operators. For example, Bitnami sealed operator that allows you to keep like secrets encrypted and just decrypt that secret just in case when they are referred by some external resources. Yeah, for example, when you mount your secret, it will be automatically unsealed. But I think like this approach is pretty complicated because you will be need to learn some new tool. So just think about this. Decrypt on demand. So this approach actually we will implement today to check how it works. So for this stuff, we will use the Mozilla SOPs. I think on some of the sessions that we had in the past, we used the Mozilla SOPs to encrypt the secrets on place. So we will just remind how to do that. So in this case, we use on our side, we use the SOPs utility to encrypt the secret. Then we push that secrets and store them in the Git. And we also share the private key for our SOPs with the Flux. And Flux will be able to perform the decryption of the resources on demand. So once it will be need to install the encrypted resources from the Git, it will use that key and just decrypt that. And again, it will store it in the Kubernetes secrets in the unencrypted way. So need to think about this. Then secret synchronized by operators. So it depends on the tool that you will use and where you will store your actually secrets. So I like the solution with external secrets operator. In this case, you will store your secrets in some secret store service like AWS Secrets Manager or GCP Secrets Manager or HashiCorp Vault or something like that. So, and the external secrets operator will automatically replicate that secrets to your cluster. But again, it still will use the secrets in the unencrypted way. And the last way is to use the CSI drivers to mount your secrets as a files. For example, the AWS Secrets Manager support that approach. So you can just store everything in the Secrets Manager, and then you will be able to mount directly from the Secrets Manager, mount it to your pods. So in this case, it won't store this sensitive information in the Kubernetes secrets. So it will operate with this information directly. Yeah, so each approach has its like pros and concerns. So you need to choose one. So we will check this for the SOPs as a basics, but like how to deal with this on the production side. So this can be a topic for the discussion. Then image automation controller. So it's actually one of the controllers that are extra controllers and are not installed by default. So how it works? This controller will monitor some Docker registry and look up for the new tags. So once a new tags will be added to the Docker registry, so the image automation controller will perform the patch to the image version. Like it will patch the image tag in some manifest, and it will push that patch to the Git automatically. So in this case, if you remember the previous schema, like when the build system sent something to the Git and that triggered the GitOps tool. So in this, maybe I will just able to show this schema for you one more time. Let's back to it. Just a sec. This one. Yeah, so this CI system actually triggered, again, it will make the update of the configuration. So in case of the image automation controller, you won't be need to perform this step. Yeah, so the GitOps tool will automatically grab the information about new artifact from image repository and actually update the manifest by its own. And then the rest of the components from the Flux will perform the reconciling of that information and perform the update of your secret. So it's like easier to use like that controller. So everything will be on place. Let's back.
Sorry, I have a little question regarding
Yeah,
this
sure.
one. It can only rely on tag difference, not like digest difference, for example. So some CI/CDs can create new tags, yet the images remained unchanged. Hence, the SHA digest is the same. So this operation is redundant and does nothing.
So this mechanism has actually the policies. So, and like here, it is a resource that is called image policy. And this resource contains the configuration, like how the update of your image tag must be performed. For example, you can just define some version range that it will apply, or point to some specific repositories that must be updated or something like that. So it depends on your needs. You can just configure all of that stuff and this behavior with image policy.
And the small question regarding the Flux itself, I honestly didn't touch it once, so I have a pretty simple question in comparison to Argo CD. So you can configure Argo CD as a hub in a hub spoke way, so you can control remote clusters from some other place with Argo. As per my understanding, Flux only works as an agent, so it controls the cluster it's installed on, right? You can't manipulate the remote clusters.
No, not at all. So it has this functionality. So for each resource, like Helm release or customization, you will be able to point to some kubeconfig file with a configuration for the class. So by default, it will work with underlying cluster, but
Oh, so you can actually, so you
yeah,
can
in
use
the
hub
resource,
spoke. Yeah.
yeah, in the resource you can pass the Kubernetes credentials, and it will work with a separate cluster.
Yeah, so it's similar to Argo in this
Yeah,
regards. Yeah. Thank
yeah,
you.
but in this case, there is an interesting question, like how to deal with this better. Like, for example, have the one Argo CD that perform the installation to the different clusters, or have a different Argo CD installation per environment. So this is some kind of discussion. And here with Flux, there is the same. It's like have a Flux installed in the
On
like
each cluster or
yeah,
have
or
it in
per
one
cluster
place.
or
Yeah,
just
yeah.
one centralized one. Yeah, so
Yeah.
Probably it's like both approaches, I think, have its own pros and concerns. So
As many other questions in our job. So yeah,
yeah,
that's a question for another session, I guess.
yeah. So I'm trying to be very accurate and with the definitions here, and most of the things can be like discussed here, but we have a limited time for that. So then,
Yeah, thank you.
yeah, let's move. Then multi-tenant. So we almost there with the presentation, and we will move to the more interesting stuff. So the multi-tenancy, just to be careful with this definition for the Flux. So it's not about the management of the different clusters. It's mostly about utilization of the single cluster by the different vendors. For example, you have a different teams that will work with your cluster, and you want to control to which namespaces and to which resources and what to install and where to install this team will be able to do. So in this case, the Flux use like splitting by the namespaces, so it can just limit the namespaces and the role-based access control. So each resource, for example, you want to create the Helm release. So in case of the multi-tenancy, you will be need to point and define the service account, and using that service account and permissions of that service account, Flask will perform like the changes to your cluster. So if the service account is like pretty limited, so in this case, in this case, you will be able to perform some fine-grained access to the system. So this totally will be enough. And for access to the Flux and in scope of this tenancy model, we have two type of roles. We have the platform admins. So the platform admins, actually, it's the persons who will be able to access to the Kubernetes and create any kind of Flux custom resources and operate in any namespace. So the tenants, actually, it's the service accounts, mostly service accounts that are configured by the platform admins. And these service accounts will be used by the Flask resources. And Flask will perform the installation of that resources, like using impersonation for this account. Yeah, so for example, we have a Helm release. We point this Helm release that it must use some specific service account, and the Flux will install all of the resources using this service account. If this service account don't have some permissions, like for example to create the secrets, so in this case it will throw the error that you don't have enough permissions. Yeah, and so it's like one of the layers that you can use. Another layer you will need to implement on your Kubernetes level. Yeah, for example, which users will be able like to perform actions with any kind of the resources. Yeah, again, this is the biggest topic. So for the Flux, we need to understand like this concept with two accounts. But we also should remember that on top of this concept, there is the concept of the management of the access to the Kubernetes at all. So it's like an underlying component that you can use, but it's not something mandatory. Yeah, you can just use your own approach. But I think it's like easier to use this one and to do not like think about some bicycles. Then the monitoring section. So it's what I usually like because most of my presentations were related to the monitoring stuff. And if you attended that sessions, you are probably familiar with the metrics collection, with logs collection. So I think one more session we need to perform with the traces collection. But let's see. The Flux components itself produce the metrics that can be collected by the Prometheus. So they have actually very detailed metrics exporters. So it allows you to gather the information about the reconciling, about the resource consumption, about the internal queue, and etc. So it's pretty big dashboard that can be presented in the Grafana based on that Flux metrics. I just show you like the main screen, but it has 5 or 6 sections, and it's very detailed, and you can understand if from this you will be able to understand if all of the resources are deployed correctly, or you have any kind of errors, or create some alerts rules based on these errors, and have some additional notification mechanism. But in the documentation, actually, I had a chance to see that they recommend to use for example, Grafana to make the notification, because they have their own notification management controller. So no need for that. And this is like the second example. Yeah, so like how many clusters were reconciled, how many manifests, how many sources, and the locations of these sources. So this dashboard is pretty detailed. So I had a chance actually to prepare it in scope of demo, but this can be like a good exercise for you, like to install the Flux, then install the Prometheus stack to gather the information about the Flux. And actually, on the Flux documentation, you will find a detailed instruction that describe how to do that. So just need to find it. And the same with the logs. The great thing that I like here, that all logs from Flux components are structured, so I don't need to parse them. So in this case, I can just gather these logs using, for example, Grafana Loki or any kind of logs collector, and just demonstrate all of that logs in the Grafana. So based on that, I will be able to, as my logs are in the JSON format and are properly parsed, so I can just collect the information about the namespaces and like filter by namespaces or by levels. For example, I just can collect information about all of the errors that happened during the deployment, and understand why it happened. So, and have the whole logs history. And now we have implementation demo. Just one more sec, I'll check the chat here. Yeah, full model looks better. So I don't know, actually, like it's a great thing that the model like that it supports both push and pull. So in scope of this demo that I performed and prepared for you, actually it wasn't to any kind of problems related to the pool. So I don't know, but I heard some histories that the AWS performed the deployments every 11 minutes. So probably in case if you need to do this immediately, so the push model will be fine for you. Okay, then let me close the presentation and let's go to the code stuff. So just to verify, can you see my VS Code?
Mm-hmm.
Okay, awesome. Yeah, so I prepared some
black screen, yeah. I don't know, it's a code already.
Yep, it's actually like almost black screen. Sorry, I just don't share anything or share. No, you're sharing the screen. Okay, let me reshare probably. Just for case.
No, we see VS Code.
Okay, gotcha, gotcha. So, as usual, I prepared the set of the scripts that will perform all of the actions for you, but we will go across all of them. So just for start, let's start Minikube on the background and check the main steps and main exercise that we will perform today.
And that's a question. Can we get the scripts after the meeting?
Yep, absolutely. As
So,
usual, we
super.
will share the blog post and I will share all of the script. Actually, I created it for you because it looks pretty because I created it for you. So in case if I created it just for me, it will be ugly. So in any case, I will share it. No worries. So the first step that we will be need to perform, it's the install of the Flux CLI. So if you work with Argo CD, you like it because it has some kind of UI that allows you to perform any kind of changes through the UI. So the Flux itself, hasn't its own UI, but there are many tools that supports the Flux. For example, view GitOps that actually provide the dashboard for the Flux. And actually we will install it and we will check how it works. But for my opinion, I don't know, there is no need for the UI for that stuff because all of the changes that you will perform, you do through the Git repo. So for example, you changed the Helm release. In any case, you will be need to push it to the Git repo. So like just manually change the configuration file and send it to the repo. But if you want some kind of UI, pretty UI, so we will take a look on it. Okay, so the Minikube is starting on the background. So in my case, like do not garbage my system, I will start the Flux CLI in the separate container. Yeah, so if you remember the session about the Spinnaker, we performed it in the same way. Just make sure that it has access to your kube config, because the Flux will use the kube config and context from that kube config to have access to the cluster. So like be careful with that. So we already started the Minikube. Let's start. Let's go to the scripts folder here. Let's start the Flux CLI here. Okay, so the container is started, then let's attach to it. Okay, let's probably join this. So I'm just trying to find the layout that you will be able to see. Okay. So we are good. Now we can work from that. So all of the scripts here from this folder are mounted in my container. So I will be able to run part of them from this folder, from the container. So the first thing that we will be need to do is set up the GitHub settings. So I won't show you this file because actually it contains my GitHub token. So just can trust me that this file contains like the export of the environment variables. Based on the access to the GitHub, you need to create some kind of token. Probably let me show you. So the token can be, you can use the classic tokens here or the fine-grained tokens. So I use the fine grains. And in this case, I selected my repository. So I created the repository where Flux will store its own state. Actually, it's not mandatory. You can just omit this step, and the Flux CLI tool will create this repository for you. But like I just prepared it and created it. And what about the tokens? So you need to have access to the contents of the repository and allow to read and write. Then also commit status. So it depends. Like commit status is here. It's mostly optional one. If you want to change the commit statuses using the Flux. So in this case, it's like you need to get these permissions, and that's all. So just create this token, set it in the file, and you will be ready. Now let's so we need to apply this. So I will do source 03 and set this setting. So it will export variables, and I will be able to use it in the next scripts. The next script is pre-flight checks. So the Flux utility itself allows you to verify if everything is ready for the bootstrap. We will make Flux. We don't need to do that. Like 04 pre-flight checks. So we have the appropriate version of the Kubernetes and passed all of the pre-checks. Now we are ready to perform the bootstrap. So as I mentioned before, I just set all these three variables later in my script. And here I just added the check that verify if you set it or not. So for the bootstrap, we use the components extra. So by default, this image reflector controller and image automation controller are not installed. So we just install 4 main controllers. But I just added this component extra to install all of the stuff. Then the token auth. So it will use, when you add this option like token auth, it will save the token that you defined in your configuration. Yeah, in the GitHub token variable. And it will store it in the Kubernetes cluster and use that token for the pulling of the information from the Flux repository. In case if you don't want to store the token, you can change the token auth to false, like this. And in this case, but it doesn't mean that you won't be need to set this token. It just only means that using that token, the Flux will create deployment keys for your repository and just store inside of the Kubernetes deployment keys. And in the future, we'll use deployment keys for that. And the last ability, so you can use like the native Git provider here, and just authorize to the repo using the SSH key. So in this case, you won't be need to use GitHub tokens at all. So it depends on your needs. So in our case, we will just store the token because in the future, we will use this token for sending of the notification. So let's make a Flux bootstrap. So it's script 05. Okay, let's go. So it's connecting to my repo and performing the installation of the Flux components. Once they will be installed, it will push all of this data to my Flux repository. Let's check. Yeah, here we are. So we have the clusters, the name of the cluster. It grabs the name of the cluster from the context. And then it will add one single directory that is called Flux system. And actually in this Flux system, it's a customization folder. So using this customization folder, the Flux will install its own components. So it's so as I mentioned before, the Flux itself manages itself from the Git repo, and I'll show you based on that resources. So nothing specific here, yeah. So it's just install, push all of the components. In case of the upgrade, you can just upgrade the manifest in the Git repo, and Flux will be automatically upgraded. So no needs to perform any kind of actions inside of the cluster. Just make a commit and push. Okay, so we are ready with this one. Let's check. So all components are healthy. Let's probably start simple dashboard and check. So we have a Flux system namespace where all the components live. So we have main components that I mentioned in my presentation. So, and each component will work with some specific custom resource. So for the custom resource, you could see the Git repositories, image repositories, Helm releases, Helm repositories, and etc. So now we can just make a miracle. For example, we want to install, let's probably first clone the repository first. So I will go to the script folder and I'll clone the my Flux repository locally, because I will be need to perform, like add the changes to my Flux repository to make it happen. So be careful because when you perform the bootstrap, you added the paths inside of the repo that it reconciled. So in case if you will add some files at the root of your repo, it won't be automatically reconciled. So if you want like the files to be reconciled, you need to put it like to this root repo, root folder that you defined during the bootstrap. After that, you will be able, in case if you want to like create some like recommended structure with like apps and infrastructure folders, you will be need to refer that folders in again in this root. I'll show you how to perform this. So we clone this and we are ready to create some kind of manifest. So I already prepared it for you, but for example, let's install the view GitOps. So to install it, we usually install it from the Git repository. We need Git repository custom resource, and also we need to Helm release. So this Helm release will create the Helm chart resource from our Git repository. And in this case, it will like create a separate namespace and install it with some specific values. Like to do not write this huge manifest, the Flux allows you to render the manifests with the CLI utility. And actually, I prepared a couple of examples for you. So let's go. So inside of our container, let's go to the home Flux folder. So I mounted our repository here. And here, let me probably create the folder here. Apps minikube. Here we are. And go to that folder, apps minikube. Now, in this folder, I can just execute some Flux command to generate the manifest. So for the view GitOps, I just need to create the source. So to create that big manifest with my chart, with my Git repo, I can just execute this simple command and it will render my manifest. Here we are. Okay. Let's make a deal here. Apps. Yeah, so here we are. And in this folder, we have this manifest that define our Git repository. So now we also need to create the Helm release here. So it's very easy. Let's generate the Helm release and append it to the same file. So we put the release name, then as a source, we use our Git repository, then define the folder where our chart lives, then define the reconcile strategy, because usually there are two ways to reconcile strategies. One is for the chart version, one is for the revision. So in case when you use the Helm repositories, in that case, chart version strategy will work fine for you. In case if it's a Git repository, you will need to use a revision strategy. Then put the target namespace, add that this target namespace must be created, and also add the pointer to the values file. So the values from the file will be grabbed and automatically injected to your manifest. So we have this stuff. Yeah, here. Let's temporarily copy it here. Okay. I don't have the access to this folder. Okay, no problem. We can just make we can just make it Chimoto. Oops. So now we are probably will be able to do that. However, it has the same name, so let's rename it here and add something like -v, like as its values. Let's try to put it to the same folder. Okay, that's fine. Now in this script, let's change that we will use GitOps -v from the same folder, and then just let's render this Helm release and add it to my directory, append it to my main file, paste. Okay, and when we will, so now we can just delete this. We don't need the values file anymore because all of the values will be injected in the Helm release resource. So as you see, it refers to charge from my Git repo and use the values from my values file. Now, one important, so I need to create two extra files to make it works. So the first file that I just need to add here, it's customization file. So in the because we will use the customize to apply all of the resources from this apps folder. So to make to refer it from clusters folder, we will refer to the apps folders. So, and to make the customization happen, we need to have the customization YAML file in the root of our folder. So let's just make a small copy, paste it here. So, and we see that like we will just gather the information from this view GitOps file. Okay, so we are almost ready. Now inside of the cluster folder, we need to add customization resource. Let's do not render it with the command. Let's just copy it. So I'll just make a copy. And I'll install it to the cluster folder, paste. So you see the cluster, the name of my cluster, and beside of the Flux, I have the apps here. So it's the Flux customization resource. Let's probably delete this dependency just committed for now. So as you see, it refers to the Git repository that is called Flux system. And actually Flux system repository, it's a repository that is created by Flux itself. So we don't need like to create it one more time. We just can reuse already existing. And then we add that we want to make a customization from the path apps minikube. So, and just add this like reference. And every time when you will be need to add some changes, just add everything to the minikube and it will be fine. So the interval is 1 minute. So the interval, you can just change this interval for each resource to point the Flux controllers how often this resource must be reconciled. So in case of this one, this resource will be reconciled every 1 minute. But using actually the Flux utility, you can just recancel on demand. So I'll show you how to do that. So we created all of the things. We are ready. Now go to the Flux repository and make the commit. So let's add all of our changes, status. Okay, so we have all of the information about our cluster and all of the files here. Okay, looks good. Let's make commit. It's m view GitOps add. Let's make a push. Okay, we pushed. Now let's do not wait until the Flux will perform the changes, and let's trigger the reconcile. Flux reconcile customization Flux system. I don't think that we need force here. Okay, waiting for customization, reconciled, and see applied revision main branch 3.8a. Let's check our repo. 3.8a. So yeah, and all of the folders here. Let's check. So probably, yeah, as you see now, Vue GitOps is already installed, and we can check the. So we use the Helm release there, so we can check the status of the Helm release Flux get Helm release. Yeah, so and you see like that we have revision and our release is ready and our version of our chart is installed. Very interesting option here, it's suspending. So I just noted before the presentation that I need to tell you about this. So each resource, each configuration for the Flux, it can be suspended and then resumed. So if you don't want to make the updates based on that resource, you can just use the Flux suspend command and then just add the type of the resource, for example, Helm release, and then name of the Helm release. So in my case, it's a Vue GitOps. So once I will execute this command, even if I will change the manifest for the Vue GitOps in my repository, the Flux won't update it. So after that, I will just need to resume it. I'll do Flux resume Helm release. The shortcut is HR and the name of it. And after that, the Flux will continue to perform the changes. So you can just, using this suspend resume technique, you will be able to freeze some resources. Now let's make the visualization of it. So we installed the Vue GitOps. Let's check which service it uses. View GitOps. This dashboard. Let's open one more time here. kubectl. Forward. As we see, GitOps -n GitOps. So let's use the same portal on our local 001. Sorry. Let's go and check. So here you need to put the default credentials. So in my example, it's admin. Okay, and I can see like it's actually a dashboard for all of the like resources of the Flux, and it allows, so the main feature that it allows you to do, it's like trigger the reconciling. For example, sources. We see that we have the Git repository, and we also have the Helm chart that is called Flux system view GitOps. So this chart were like created by the Helm release. So as I mentioned before, we can just create the Helm chart and then just refer to this Helm chart in the Helm releases, or we can just put the template of the Helm chart in the Helm release and it will automatically create it. So in our case, it's automatically created it for us. And as we see in the application, so we have the view GitOps in the Redis status, and you see like that it use the, so once we will open it, we can see, so there is no dependencies yet, but in the graph, you see that the Git repository is used by this Helm release. And we can see all of the events that happens, the YAML manifests. So there is no ability to edit it, but you can just at least examine it and understand if it's updated or not. And in case if you need to make a reconcile, just click this button. So the same, you can just also make the suspending and resume. So it depends. Now let's make a couple of different experiments here. So we have, so here we created the chart automatically. Let's create chart manually. So in this case, I will just create the source. So this source, it will be actually the Helm repository, not the Git repository right now. And after that, let's create the separate chart resource. And then in the Helm release, let's refer to this Helm chart resource to perform the installation. The main thing, interesting thing, that by default, the Flux support the access to the custom resources in the different namespaces. So to make this, you need just put the name of the resources, then dot, and then the name of the namespace. So it supports the cross access, but you can just, and it's enabled by default, but you will be able like to disable this. Let's make it. But beside that, let's create the infra folder. So in this infra folder, we will have 3 subfolders. We will have the controllers, we will have configurations for that controllers, and also we will have the secrets. So to demonstrate you how the SOPs works. Let's probably create the infra. Let's copy it. So just to store the time, let's copy it. Okay, but I'll just remove something from here. So I don't like this. So I remove the source here just for case. I'll temporarily remove it. Also, I will be need, as I created this infrastructure folder, I will be need to add some extra pointer here. So I will be need to add a couple of customization resources that will reconcile the manifests from my infrastructure folder. So, and as I have 3 subfolders, controllers, configs, and secrets. Yeah, so in this case, the secret won't work. I will just remove it. So in this case, it will grab the information from this infrastructure folder and automatically reconcile it. So I'll put it together with my apps YAML. So here now in the apps YAML, I can just add the dependencies here that is called infra-config. So it means like this customization file will be reconciled only after reconciliation of the customization config that is called infra-config. So and here in the infra-config, sorry, in the infrastructure here we have this infra-controller, infra-configs, and let's remove these infra secrets for now. So we will just add it later. So as you see, it adds the configs, and configs will be depends on the controllers. So it means like here we will install the cert manager, and after that we will use the cert manager custom resources like to be installed. Yeah, so here in the customization, I added cert manager. And here in the customization, I added, so in each folder, you will need to have this customization. If you want to work, especially with manifests, not with the charts, so you will need to have this customization YAML file. So here is everything is correct. Controllers here on place and here on place. The one thing that we will be need to do is let me think. So this cert manager controller is installed. So it's built in the same way. So we use 2 commands. We use this command to create the Helm repository, and this one second command to referring this Helm repository, create the Helm chart and Helm release. So I want like execute it one more time. So we have the manifest. Let's finish this quicker. Okay, so I added it here. Here I added a cluster issuer. So looks good. Now the one thing that I will be need to do is just commit everything. So git add, git commit. Let's make something like cert manager, added, push. So and probably we can just trigger the reconciliation from the dashboards here. So let's go to the applications, select the Flux system, and click to the reconcile. Let's wait. Okay, so and as you could see here, so I have a problem. So I can so my infra configs is not ready because it waits for the infra controllers. So the infra controllers is still reconciling. So the cert manager is a part of my infra controllers. So once both of these will be reconciled, so after that, both these two will be fixed. Okay. So third infra configs. Okay, it's ready, and this one will be also automatically ready. So once infra config will be ready, it just needs some time to be updated. So no worries about this. So when I go to the cert manager, I already have the certificate manager installed, and I also have the cluster issuer. So here is it, and it's also created. So in this case, I can just build some dependency tree and then just make dependency between the different components. So just use this depends on option. So this option actually can be added through the command lines, and it will be injected to the manifest. Just for your information, so just in case if you want to use some Flux Helm, create Helm release, just add something like -- help to see which parameters it accepts. So it accepts almost all possible parameters here. So, and you won't be need to write the manifest by your own. And actually, this is a good way to automate all of that stuff. Now, the last thing that we just checked today, and probably let's miss the alerts configuration because we have a limit of time. So probably let's leave this time for the discussion better. The secret stuff. So I will be need to copy this secrets folder. And I will add it to my infra here. As you remember, I just removed in this Flux system, I removed the customization for my secrets folder. So I will need to just restore it. Okay. So it's probably can be like confusing why we create it in such a way. Oops, sorry, not this one. But just for your understanding one more time. So in this cluster minikube folder, so the Flux system at all, yeah, if you will take a look on the Flux system. So the Flux system is configured to this folder and listen this cluster folder. Let me show you on the graph. Oh, here we are. So as you could see here, so the Git repository for Flux, and you have also customization. So it installed the customization file for Flux. And this customization actually is referred this cluster minikube folder. Just a sec, where is that? Yeah, as you see, cluster minikube, and just make the reconciliation every 10 minutes. So in this case, if we will add some configs to this cluster minikube, it will be also automatically rendered. So, and the easiest way to gather another manifests and apply it to the cluster, it's the customization. So we just add an extra customization that where we point to make a reconciliation, but in the different folders of the same repo, and that's all. And we just reuse this Git repository that is called Flux system. It's like circle dependencies. Okay, so I just added this stuff here. And very important stuff. So when I added this customization here, and I will just perform operations with the encrypted data, I will add an extra option that is called decryption. In decryption, I added the provider SOAPs and make the secret ref. So I will use this the information from this from the secret to make the decryption. And in the same time, I have two files. I have SOPs YAML that defines that I want to make the encryption of all of YAML files and encrypt the data and string data fields only there. And just for case, I added the part of my public key. So the rest of the public key will be used for the encryption, and my private key will be used for the decryption. So just to remind to myself, I need to export my my private key and create. Just a sec, I just forgot the name of the secret that it must SOPs pub. Just a sec. I just want to understand. SOPs. I think it's a SOPs ESC. Yeah, it's a SOPs ESC. So I will use this subcommand, but before that I will need to just export my private key here. Export to the file, secret key, and I will call it SOPs ESC. Then I just need to make it happen. Here's it. Probably I can just put it here. So I will need to do it like this. Go to the okay, projects, community Flux. Execute this command to create the encryption secret and use the local file SOPs ESC. Okay, so this secret is created, so I can just remove these SOPs. Now, to make the encryption and decryption, so I just need to go to the appropriate folders, infrastructure secrets, infrastructure minikube secrets. Let's check. Okay, I have this customization YAML file that includes my secret, and I have already encrypted. Yeah, so for this stuff, I will use this shortcut. So just to show you how it looks like. So I go to this folder. This folder contains .sops YAML, and I will do decrypt. Is just to show you. Sorry. Just to show you how these secrets files look like. So it's a standard secret file, and here in the base secret, base 64 is encoded like my secret, something like that. Yeah. Now let me encrypt it back. Okay. So now, as you can see that so actually the SOPs can use not only like GPG keys for that, it can just be as a middleware for the AWS KMS or GCP KMS or HashiCorp Key Vault. So it depends on how you want to use this. Okay, so I encrypted it with and actually in the documentation for Flux, you will find all of the instructions. Okay, we created all of that stuff. Here we are okay. We can just merge everything back. Let's go to the root of our repository. Git add git commit secrets added. Let's make Let's trigger reconciliation just for case to do not wait 10 minutes. Um, mhm. So here there is some problem. Pilot to get data key required. I could not decrypt with PGP. Interesting. Okay, interesting. So let me check the Flux system. The secrets, SOAPs, GPG, and here's my private key block. Interesting. Interesting. Probably it must be fine. So probably it's just a sec. No, it should be fine. So probably some. Okay. So it's reconciled now, or it's tried to reconcile it one more time. Oh no. So there is still error here. Just want to check if I configured this stuff correctly. Secrets, infrastructure, cluster. Here is it. Secret provider. So that's absolutely weird. Why it doesn't work? Because it was working before. Probably I need to use a little bit different mechanism. So probably we can just use it like this and try to make it one more time. So, but beside this FP, I will be need to find GPG list secret keys. So here is my ID. And then I will be need to whoops. Okay, divctl. Source GPG.
Or you can pipe it into patch. Oh, no.
Yeah, something like that, but time. Okay, so the secret is created. Secret is not found. Let's make a reconciliation one more time. Okay, let's check I added it correctly here or not. Okay, so it's absolutely weird why it doesn't work, but like there is no there is no time to make the investigation. So probably let's move to the discussion. Before the discussion, let's check. So what could be the next point of this topic? So I just want to recommend it to use some tool that is called Flagger. So it's a part of the Flux CD that allows you to perform some canary releases. Probably somebody will be able to perform some demo for the community, or if you will request it, I will be able to do that for you. And now, yeah, let's go to the Q&A.